All right, this set of screencasts is going to cover Module 6, Lessons 1, 2, and 3. To me, it makes sense to cover them kind of together because they are all talking about different ways to write an equation for a linear function. Okay, so Module 6, Lesson 1 is slope-intercept form. Remember, that's y equals mx plus b. And actually, the rule that we'll get to is down here on the page, on the bottom of page 248. Okay, so that's what is covered in Lesson 1. Lesson 2 goes over another way to write a linear function, and that is called point-slope form. And the way that you write point-slope form is down there at the bottom of page 259. And then Lesson 3, if I can ever get to it, Lesson 3 is writing a linear equation in standard form. Remember, standard form is in the form of ax plus by equals c. Okay, so we're going to go through all three of these lessons sort of together, but we're going to start with Lesson 1, which is slope-intercept form. So make sure you join me for that. Okay, so I wrote in what the slope-intercept form is. It's y equals mx plus b. Remember that m is slope, and the b in the formula represents the y-intercept. And this is a convenient way of representing a linear function if you know the slope of the line and the y-intercept. Some of those other forms might be more convenient if you know some other things. But for this one, if you know slope and y-intercept, or you can figure them out from a description, then this is a convenient equation for you to use in order to represent that linear function. All right, so let's get right into an example. It says that Andrew wants to buy a smartphone that costs $500. His parents will pay for the phone, and Andrew will pay them $50 each month until the entire amount is repaid. The loan repayment represents a linear situation in which the amount y that Andrew owes his parents is dependent on the number of x payments that he has made. Okay, well, when he has made 0 payments, then the y value is $500. The rate of change in the amount Andrew owes over time is $50 a month. The y-intercept of the graph of the equation that represents the situation is 0, 500, because that represents a point on the graph. The slope, because he is reducing his amount by 50 a month, the slope really is a negative 50. So it says use the y-intercept to plot a point on the graph of the equation. All right, the y-intercept is 0, 500, remember. So plot the point, and that's going to be right here. Okay, so he starts off owing his parents $500, you know, when he first buys the phone after 0 months have gone by. Just a reminder, this equation fits y equals mx plus b. His slope, because he's paying down the amount by $50 a month, his slope is going to be a negative 50. And where the graph hits the y-axis is at 0, 500, so his y-intercept is 500. So if you take those two things, you can actually write this equation in slope-intercept form. Okay, where, remember, x is the number of months. So after 1 month, 1 times negative 50, that's negative 50, plus 500. So after 1 month, he's down to $450. And after 2 months, 2 times negative 50 is negative 100. Negative 100 plus 500 is 400. Okay, and you can see that he is paying this down by $50 a month each month until he finally gets it paid. And a little bit of thinking will tell you that it's going to take him 10 months to pay that back. Okay, you could fill this stuff in, but basically we've gone over most of it on the previous page. They just give it to you step by step back here. You're going down by $50 every month, which is what they want you to do. Count down 50 units and over 1, and you could actually plot the whole thing here. How can you use the same method to find 2 more points? Well, you just substitute how many months have gone by. 1 month, has 2 months gone by? Should it be 3 months, 4 months, etc.? And then plotting the points, just you put in the number of months and you'll get the y value that goes along with that number of months. We've already said from the previous page that it's going to take him 10 months to pay off that loan, because he's taken, basically he's taken out a loan from his parents of $500 and he's paying $50 a month, so that's going to be 10 months because 10 times 50 is 500. Okay, this explanation down here is sort of a proof about how the slope-intercept form is in the format that it is. Okay, so if you considered a line with a slope m and a y-intercept b, and the slope formula, remember, is y2 minus y1 over x2 minus x1. Well, if you had whatever the y-intercept was, which would be 0, comma, whatever y value the y-intercept is, you could use that for your first set of points. You could use some other x and y for your second set of points. So if you know these, if you're going to use these 2 points, you can actually put it into the slope formula and do a little bit of rearranging, and you find that after you rearrange it and solve it for y, you do get the slope-intercept form. Okay? So if a line has a slope m and a y-intercept of 0, comma b, then the line is described by the equation y equals mx plus b. That is your slope-intercept form right there. Okay? All right, let's go on. Okay, could you write an equation of a line in slope-intercept form if you had a slope and a point? And the answer is yes. So what you would do is you would start out by finding the y-intercept, because obviously you want to write the equation in slope-intercept form. So I'm going to use y equals mx plus b. There's my format. I have an x and a y value, and I have an m. So I'm just going to put the x in where it says x. I'm going to put the y in where it says y, and I'm going to put the m where it says m. And I do all that, and the only thing I have left to solve for is b. Okay, so if I do all the math, I come up with -1 is equal to b. So I've actually taken some information and found my y-intercept, and then I can write the equation in slope-intercept form. Okay, because I already had the slope, I had a point which helped me find the y-intercept, and so now I have the y-intercept and I can write it in slope-intercept form. All right, so before we go to example 1b, I just wrote myself a note out here because I have a feeling that when we start doing practice, we might have some situations where, hey, they gave you a point and a slope. How do you get the slope-intercept form? So this is a great example of what you would do if you were given 1 point and a slope, and how you would find the y-intercept so that you can write the equation in slope-intercept form. Example 1b actually gives you the y-intercept, 0, 5, and another point. So b is going to be our example of how you're going to get the slope-intercept form when you have the y-intercept and another point. Okay, so that's what we're about to go through in just a second. All right, so we're going to use the slope formula, And it says we're going to substitute 0, 5 for x1, y1. And we're going to substitute 2, 13 for the x2, y2. Okay? Remember, your slope is y2 minus y1 over x2 minus x1. Okay. So let's plug and chug. All right. So y2 minus y1 divided by x2 minus x1. And I get 8 over 2, which is equal to 4. Okay, so we have a slope of 4, and then we need to keep going. It says to substitute the slope and the x and the y coordinates of either one of the points. So either point will work as long as you just stick with that one point. Don't mix and match, in other words. Plug those into the y equals mx plus b equation. So you're going to put your y value here. I decided to use x2 and y2. Y value equals slope, which is what we determined to be 4, and then the x value that gets paired up with that y value, which is 2, because our second point was 2, 13. So y equals mx plus b. So 13 equals 8 plus b, do a little math, and the b is equal to 5. Okay? I went ahead and did what if you had used the other point? Well, I can use the point 0, 5 and put it into the y equals mx plus b, and I would still get, because 4 times 0 is 0, I would still get 5. I would still get 5 for my b, because this would go to 0. All right, so it really doesn't matter which point you use. You can use the 2 points to find the slope, and then you can put the slope and one of the points in to generate your y-intercept, although frankly they told you the y-intercept up here. But if it had not been the y-intercept, you could find the y-intercept. Okay. All right, so this lovely little math fairy tale ends with the equation of the line being y equals 4x plus 5. Okay.